From the past several videos in this unit, you've learned how to classify soils, and you've learned that some plants tolerate more or less salts, depending on the plant itself. So you learn how to classify soils based on if a soil is saline, if it's sodic, or if it's saline sodic. And you learned about that for a reason, because if you have these types of soils, there are ways that in which you can attempt to remediate these soils. So let's first talk about saline soils and the remediation of these types of soils. The steps to remediate these soils are pretty straightforward. First, you need to establish drainage, like you see in these two pictures at the bottom. Then you simply need to leach salts from the root zone to reduce electrical conductivity, right? So what you need to do is leach with good quality irrigation water, right? We'll talk about that on the next slide, right? The irrigation water cannot be salty, or else you end up at the same point that you're at currently in general. And then once you're done, if you can use good quality irrigation water, you should soil test to determine success. And we'll talk about this in more detail in some other videos. What I want to do is share with you the remediation of saline soils. And what do you need? You need plentiful, good quality irrigation water. And you also need good drainage, like we mentioned on the previous slide. And I should have mentioned good quality irrigation water on the previous slide. It should have been written on the previous slide. But I put it on this slide because there's a general relationship between the leaching of salts and the amount of irrigation water that you can apply. And this is what you oftentimes would see in terms of salt removal in the top 12 inches of soil. If you added 6 inches of water over an acre and let that move through the profile, you would remove roughly 50% of the salts that are present in the top 12 inches. And if you added 12 inches of soil, 12 inches of water, or 24 inches of water per acre, you would remove 80 or 90% of the salts within that top 12 inches of soil. So this practice on paper is relatively easy. And to add 24 inches of water actually is probably what you would add in a growing season in an arid or semi-arid area for corn, but you wouldn't add it all at once. And the concept here is you want to add this water, maybe not all at once, but over a short period of time to force leaching to occur. And that's a challenge. Another option is to use something called a range pitter, right, which increases aeration. And this device basically has tines that move up and down and punches holes into the soil to improve or allow for greater movement of, let's see, it says it's you're punching holes to improve drainage is what you're doing in systems that may be affected by salinity. Another thing you could try to do is mulch, and it's not shown in the picture, but if you added a mulch or if you had the soil surface covered with residue, that's going to reduce evaporative losses. And instead of salts moving towards the soil surface, if you could add water, that would help alleviate salts from being near the soil surface and help push water and salts down through the profile.